All right, we have number 13 of our SAT prep for math, which is our calculator section, this particular part. So our graph here listed is showing the change over time in milliseconds in a neuron's membrane potential in millivolts during an electrical brain signal known as action potential, at which of the following times in ms, which is milliseconds, is the membrane potential closest to negative 70 millivolts. All right, this gives you a lot of information. Now remember, this isn't science. This is math. We're dealing with the numbers explicitly. So what part of this is important? Really just negative 70. It gives us a graph. We know the graph has some numbers in x, some numbers in a y, right? We don't even care what those are really. We just know we have x's, we have y's. It's asking us where negative 70 is for the graph, right? At which of the following times is the membrane potential, which is membrane potential, this whole thing. This is just y. Membrane potential, right? Y. So which of the following times? Oh, time, what's that? X. Oh, look, where cross off makes it x. So this whole thing we crossed out, and that's just x, right? So at which of x is the y closest to negative 70? That's our real question. This whole thing, like this whole thing, is just information that you don't need. You can just cross it out. That's why it's super important to know what the question's asking you, right? You get caught up in trying to understand what milliseconds and millivolts are and action potential and the neuron's membrane potential. You don't need to know the chemistry of how your neurons work in your brain, right? You don't need to know the physics of that. You don't need to know that it's measured in millivolts or milliseconds. You need to find out what x is closest to that negative 70 for y. All right, so let's do that. So what x is closest to negative 70 for y? We know negative 70 for y is going to be below 0. So you go until we find negative 70. We know it's between negative 60 and negative 80, right? And luckily for us, the one right in the middle has a little tick mark on it. So it's going to be where it's on this line. We see there's 2 points, the initial point at x equals 0, and this point, which falls right here. So we know it's between 1 and 2. So at which, oh, there's also one over here. We didn't keep going, look, it rolls back up. So there's also one at 5, exactly. All right, so at which of the following times, which is x, at which x is the y closest to negative 70? It's going to be either at 0, at like 1 point something, because it's between 1 and 2, or at 5. And we see our answer is listed as 5, because 0 is not there, and 1 point something's not there. And that's where that key term closest comes into effect, because like 2 is close to it relatively, but 5 is way closer to 5, right? So, or like 4.99 is way closer to 5, right? So our answer is D. Don't need our calculators again. Look at the problem, see what it's asking, eliminate other potential misinformation that you don't need. Find out what they're asking you, you get our answer of D, which is 5.